Okay, we're back again. I did some more research and I've got a few more to film here. So now we're on the line 17q, the heliocentric universe, celestial mechanics, Principia Hipparchus Ptolemaic while SETI, and this is part 95. And it's based on the line 17 while SETI alien radio signal from 1977. The math equation is 14, 1, 1, 13, 2, and 1. In case you're joining us, you want to start at line 17A video, because all of these are from the data from line 17, and I've just broken them down into smaller videos. However, I do have news for you, and when we get to 17T, some of the videos are going to be quite long. I've actually divided them up 5 times, and they're still long. But there's a lot of really interesting information that came up, so we're going to go with it. So this is a picture of what it looked like, the heliocentric universe. And this is what I found out about it. The heliocentrism, which is the lower panel, is in comparison to the geocentric model, the upper panel. As you can see, yellow in the middle means the sun, and blue in the middle means the earth. So for the geocentric model, that basically before, in the early centuries, we thought that the whole universe revolved around the earth, and now they're saying that it revolves around the sun. Okay? The different dots are the different planets. This is Earth. This is the moon. I'll do it down here. Oh, sorry. This is the sun. This is Mercury. This is Venus. This is Earth. This is Mars. This is Jupiter, and this is Saturn. So the modern analytic celestial mechanics started over 300 years ago with Isaac Newton's Principia of 1687. The name celestial mechanics is more recent than that. Newton wrote that the field should be called rational mechanics. The term dynamics came in a little later with Gottfried Leibniz, and over a century after Newton's, Pierre-Simon Laplace introduced the term celestial mechanics. Nevertheless, prior studies addressing the problem of planetary positions are known going back perhaps 3,000 years or more, as early as the Babylonian astronomers. I found that on the wiki files under celestial mechanics. Okay, so let's go over here for a minute. Okay, so heliocentrism or heliocentrism is the astronomical model in which the Earth and planets revolve around a stationary sun at the center of the universe. Geocentrism, which places the Earth at the center. The sun makes a slower circle eastward. Over the course of a year, the planets have similar motions, but they sometimes move in the reverse direction for a while, retrograde motion. I never knew that. So that's something I didn't really take the time to look at, but that's quite interesting. I always thought they always went in the same direction. Ptolemaic system is this one here. The basic elements of Ptolemaic astronomy showing a planet on an epicycle with an eccentric deferent and an equant point. And here's the book from the 1550s, Sacro Bosco Tractatus de Sabera, with the Ptolemaic system showing it. So I guess it was written back in the 1500s. In the Ptolemaic system, each planet is moved by a system of 2 or more spheres. One called its deferent, the other its epicycle. The deferent is a circle whose center point exists halfway between the equant and the Earth, marked by the X in the picture to the right, where the equant is the solid point opposite the Earth. Another sphere, the epicycle, is embedded inside of the deferent and is represented by the smaller dotted line to the right. A given planet that moves along the epicycle at the same time the epicycle moves along the path marked by the deferent. These combined movements cause the given planet to move closer to and further away from the Earth at different points in its orbit, and caused observers to believe that the planet even slowed down, stopped, and then moved backwards in retrograde motion. So the Ptolemaic order of spheres from Earth outward is Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, fixed stars, sphere of prime mover. And then gravitation, it says Johannes Kepler, after analyzing Tycho's bronze famously accurate observations, constructed his three laws in 1609 and 1619, based on a heliocentric view where the planets move in elliptical paths. Now, we did cover this in an earlier video, so it's kind of cool that we are finding out what it was talking about now. Using these laws, he was the first astronomer to successfully predict a transit of Venus for the year 1631. The transition from circular orbits to elliptical planetary paths dramatically changed the accuracy of celestial observations and predictions. Because the heliocentric model by Copernicus was no more accurate than Ptolemy's system, new mathematical observations were needed to persuade those who still held on to the geocentric model. However, the observations made by Kepler using bronze data became a problem not easily overturned for geocentrics. In 1687, Isaac Newton devised his law of universal gravitation, which introduced gravitation as the force that both kept the Earth and planets moving through the heavens and also kept the air from flying away, allowing scientists to quickly construct a plausible heliocentric model for the solar system. In his Principia, Newton explained his system of how gravity, previously considered to be an occult force — I kind of laughed when I read that one. Yeah, they actually thought we were kept on this earth through an occult, supernatural thing. So, conducted the movements of celestial bodies and kept our solar system in its working order. His descriptions of centrifugal force were a breakthrough in scientific thought and finally replaced the previous schools of scientific thought, i.e. those of Aristotle and Ptolemy. However, the process was gradual. So I'm not going to read everything here. I just bolded the stuff I need to look at, okay? You can see most of it on Wiki at the Ptolemaic system. So, a geocentric frame is useful for many everyday activities and most laboratory experiments, but is a less appropriate choice for solar system mechanics and space travel. While a heliocentric frame is most useful in those cases, galactic and extragalactic astronomy is easier if the Sun is treated as neither stationary nor the center of the universe, but rotating around the center of our galaxy, and in turn our galaxy is also not at rest in the cosmic background. Okay, so that's going to go there, and we're going to go to the notes here. Sorry, I'm just making a note that I'm filming this or else I'll forget I did it. So I'm just going to go back over to my notes over here. And I think I read that part there. So my thoughts, January 20th, 2012 at 7:02 p.m. Eastern Standard Time. Maya comes up to mind when I see 3,000 or more years for modern analytical celestial mechanics. Isaac Newton's Principia of 1687, from this quote here. This is a geometric construction used by Hipparchus in his determination of the distances to the Sun and the Moon. That's how he calculated their distances back in his day. And we're talking many moons ago. The geometric definition is when a circle's diameter is 1 unit, its circumference is pi units. In Euclidean plane geometry, pi is defined as the ratio of a circle's circumference c to its diameter d. And of course, we did a whole section of pi on line 17R. Here's the Ptolemaic order of spheres from Earth. That's what it looks like. Celestial mechanics is the branch of astronomy that deals with the motions of celestial objects. The field applies principles of physics, historically classical mechanics, to astronomical objects such as stars and planets to produce ephemeris data. Orbital mechanics, astrodynamics, is a subfield which focuses on the orbits of artificial satellites. Lunar theory is another field focusing on the orbit of the moon, and that's under celestial mechanics on Wiki. Here's the old book that they wrote. Sir Isaac Newton published this on the 5th of July, 1687. So that Principia theory is actually still being used today in 2012. Philosophiae Naturalis Principia Mathematica, Latin for mathematical principles of natural philosophy, often referred to as simply the Principia. It is a work in 3 books by Sir Isaac Newton, first published in the 5th of July, 1687. After annotating and correcting his personal copy of the first edition, Newton also published 2 more editions in 1713 and 1726. The Principia states Newton's laws of motion, forming the foundation of classical mechanics, also Newton's law of universal gravitation, and a derivation of Kepler's laws of planetary motion, which Kepler first obtained empirically. The Principia is just regarded as one of the most important works in the history of science. So this is in the heliocentric model. This is Venus's orbit. Now I found this and I posted it here because I've seen this before, but I don't know where. This is eastward, conjunction full, eastward, superior planet, superior conjunction full, inferior planet, this is the sun, inferior conjunction new, greatest western elongation, great eastern elongation, earth, western quadrature, eastern quadrature, and opposition full. I don't know what that means. Venus is huge when it's a crescent because it's closer to Earth, and small when it's full because it's on the other side of the sun. And that's from the scienceblogs.com. And here's the old geocentric model. I guess there was 2 different geocentric models. So it shows the planets, the sun in a different spot. Okay. So January 24th, 2012, 9:40 p.m. Eastern Standard Time, my thoughts. I learned something new from all this. I always assumed that the Earth was the middle of the universe. I didn't know it was the sun. Interesting theories on both parts, and I don't know if they have made up their mind yet, because it seems they are using both types of charts to figure star charts out, even to this day. I could be wrong. Let me know if I'm wrong about this and give us a reference of where to find the proof as to where it says differently. Here's a thought. The James Webb Telescope finds out that we're part of an even bigger universe and that our solar system is one of the little systems in it. Now, wouldn't that be something? That would definitely mean there is alien life forms out there living on other habitable planets. They must be trying to communicate with us. We just have to figure out how to answer back in their languages so that they can understand what we are saying. Now that's the end of that video, and next is 17T.